This is the lesson 3.2, teaching point and mini lesson. So today you will be skilled at analyzing proportional relationships and using them to solve real-world math problems. You will also be skilled at solving problems using percent proportions. So you're going to see a lot of similarities back to chapter 1. Okay, so I have color-coded this lesson. So what we're going to be looking for is determining always parts, whole, percent, and then the 100 I'll explain in a minute. So every time we're talking about a part, I'm going to be using red, a whole I'm going to use green, a percent I'm going to use blue. So when I mark my text, that's going to help me. So we're going to do 3 different types of problems here. First one says to determine a part given a percent and a total. So I'm determining a part, so I'm determining the red here. So I'm just going to go in order through this. When we read through here, Tamara has a total of 250 sports cards in her collection. Okay, 250, it says total, so that's a whole. So I put this in green. Of those cards, 30% are baseball. There's my percent, so that's blue. Question asks, how many baseball cards does she have? So she has a lot of different sports cards. Part of those cards are baseball cards, so that's why I did that piece in red. So here's how we're going to look at solving this. We're going to use the proportion part to whole equals percent over 100, and we're going to use that all the way through today. So first step is to substitute the values into the proportion. So I don't know the part, that's what I'm trying to find, but we know the whole was 250. So I don't know the part, the whole was 250. The percent was given, that's 30, and when we say percent, that means 30 per 100. So that's why I have the 100 here. Now I can't scale this up all that nicely. Maybe I could by multiplying by 2.5, but I chose to solve using means and extremes. So I did 250 times 30, the means, is equal to the extremes, 100x. Now I multiplied 250 times 30, I get 7,500 equals 100x. Now I need to isolate for x, so I'm dividing both sides by 100. And when I do that, I get 75 equals x. So now I want to make sure that I state my answer in the context of the problem. So Tamara has 75 baseball cards in her collection. That's what this stands for. And I can easily go back to the question, how many baseball cards does she have in her collection? So she has 75 baseball cards. Okay, our second example here is it rained on 9 of the past 25 days. So I can see here 25 days would be the total days or the whole, so that's green. That means 9 of the days is just part of the days, so that's my red. What is the percent? They're asking me the percent, so that's my blue. So again, I'm using the same proportion, part to whole equals percent over 100. So I'm going to substitute the given values into the proportion. I know that 9 was the part, so it goes in the numerator. 25 was the whole. I don't know the percent, so that's my x, and the percent always goes over 100. Now I'm going to solve for the unknown quantity. Again, this time I could have easily just scaled up and said times 4, and gotten my answer. But I'm just going to continue to reinforce how we do means and extremes because this is really important for solving equations later. 25 times x is equal to 9 times 100. Okay, now I can multiply here. So I multiply 9 times 100, so 25x is equal to 900. I'm going to isolate for my variable, so I need to divide each side by 25. And when I do that, I get x is 36. Same thing I would have gotten if I would have scaled up. So I would probably scale up if this were my assignment. Now I need to state my answer in the context of the problem. It rained 36% of the days. So again, go back to the question. What is the percent of days that it rained? 36% of the days it rained. Okay, the last example This is determining a total. So this was determining the percent. Now we're doing a total. A basket contains 14 red apples. The rest of the apples are green. So I know I have some green, some red, so this is only part of them. That's why I did this in red. The rest of the apples are green. The number of red apples is 70% of the total number. So there's my percent. That's why I did that in blue. Here it's asking how many total apples. That would be the whole. So again, using the same equation, part to whole, percent over 100. Substitute the given values. We know the part was 14, so the numerator is going to be 14. I this time do not know the whole. That's what I'm trying to find. The percent was 70. So again, here, not too sure about scaling that down. I'm going to use means and extremes. So I solve my proportion here. So 70 times x, 70x, equals 14 times 100. Now I'm going to multiply. So 70x equals 1,400. I'm going to isolate for my variable. Divide each side by 70. When I do that, I get x is 20. Now I need to make sure that I state my answer in context of the problem. It means there are 20 total apples in the basket. Go back to my question. How many total apples are there in the basket? There's 20. 14 of them are red. The rest of them then are green, but the total is 14.